Um, Hi, guys. Today I will introduce some academic papers that tackle fascinating challenges in the field of artificial intelligence. And these papers cover a wide range of topics, from fine-tuning language models for autonomous systems to improving negotiation processes in online marketplaces. We'll also explore how language models can enhance decision-making, create human-like interactions, and analyze sentiment. Additionally, we'll delve into the exciting applications of language models in healthcare, animation generation, and financial analysis. Um, get ready to be inspired by the innovative solutions presented in these papers. The paper INA introduces a negotiation dialogue agent for online marketplaces. It addresses the need for an agent that can engage in integrative negotiations, including price negotiations and negotiations on other aspects like product bundles and delivery. The paper's main contributions are: one, creating a new data set called integrative negotiation data set for training the agent. Number two, developing a reward-based dialogue system, INA, that incentivizes the agent to learn effective negotiation strategies. That's the original scale Resenter experiments. But three, demonstrating through experiments that the proposed approach significantly enhances the agent's negotiation. The paper asked more, no better addresses the problem of needing high quality prompts and large language models for effective decision making. The paper introduces the bi-level LLM framework, which combines prompt generation, chain of thought reasoning, and action policies. The framework learns to generate relevant prompts and uses a reasoning to guide decision making. The paper's main contribution is the integration of these components to improve the performance of LLMs. The paper Duma introduces a conversational agent framework that aims to create human-like interactions. It utilizes two generative large language models called FastMind and SlowMind. The FastMind module handles simple scenarios quickly, while the SlowMind module engages in careful planning and reasoning for complex challenges. Duma seamlessly transitions between intuitive responses and deliberate problem-solving processes. Based on the conversation's complexity, the paper demonstrates the effectiveness of Duma in the real estate industry, showing significant improvements over baseline models. The paper, Large Language Models for Aspect-Based Sentiment Analysis, explores the use of advanced language models to analyze and understand people's opinions about different aspects of a product or service. The authors found that these large language models, when fine-tuned for the task, achieved excellent results in accurately identifying and classifying aspects and sentiments. They also discovered that detailed prompts were not necessary for these models to perform well. This research offers a cost-effective solution for analyzing sentiment, providing accurate results with lower overall cost. The paper, Shilin MedVL, introduces a new Chinese large vision language model called Qilin MedVL. which is designed to interpret medical data using images. The paper addresses the lack of such models in languages other than English, and the need for models that can understand multimodal input in healthcare. The main contribution of the paper is the development of Chilan-Medveal and the creation of the SheMedVeal dataset, which consists of over 1 million image-text pairs for training and evaluating the model. The paper also discusses the limitations of the study and the ethical considerations of using large vision language models in healthcare. The paper Aspero aims to solve the problem of turning structured data into short sentences using large language models. It introduces the Aspero approach, which uses a pipeline consisting of the nshot generator and the consistency validator. The nshot generator generates verbalization attempts using multiple language models, while the consistency validator assesses the quality of the sentences using a specialized prompt. The paper evaluates Aspero on different data sets and shows that it reduces errors and performs well compared to other models. However, there are limitations such as the cost of using language models and the need for context integration. The paper From Values to Opinions addresses the challenge of predicting people's opinions and behaviors in real-life situations, which can be time-consuming and expensive to collect through surveys. The authors propose a method called value injection method, VIM, to inject specific value distributions into large language models, LLMs. They conduct experiments to test the effectiveness of VIM and compare it with baseline approaches. The results show that value-injected LLMs outperform the baselines in predicting opinions and behaviors. This paper's contribution lies in providing a more efficient and accurate way to predict human behaviors and opinions. It has the potential to save time and resources in collecting data, and can be valuable in various fields such as marketing and social sciences. The paper Clover addresses the problem of ensuring the correctness of AI-generated code. It introduces the Clover paradigm, which simplifies correctness checking by focusing on consistency checking. The paper proposes a checker that verifies the consistency between code, docstrings, and formal annotations. It also presents the Clover Bench dataset, which contains examples for evaluation. The paper demonstrates the feasibility of using GPT-4 to generate formal specifications and evaluates the verification phase using GPT-4 and the Daphne verification tool. The paper utilizing language models for energy load forecasting focuses on predicting energy consumption in buildings and cities. This is important for managing energy usage efficiently. The paper proposes a new approach that uses language models to make accurate predictions. They convert energy data into descriptive sentences using prompting techniques and fine-tune language models. These models can then generate predictions for different time periods. The paper's contribution lies in its innovative method and its ability to outperform traditional forecasting methods. This research has the potential to improve energy efficiency and help make smarter decisions about energy usage. The paper, Data-Centric Financial Large Language Models, addresses the challenge of using large language models in complex domains like finance. It proposes a data-centric approach using a financial large language model, or FLLM, to pre-process and pre-understand financial data, improving the handling of financial tasks. To overcome the lack of labeled data, the paper introduces abductive augmentation reasoning, AAR, to automatically generate training data for FLLM. The experiments show that the data-centric FLLM with AAR outperforms baseline financial LLMs, achieving state-of-the-art performance on financial analysis and interpretation tasks. The paper mPrompt introduces a method called multi-level prompt tuning, or mPrompt, to improve machine reading comprehension. It addresses the problem of the resource-intensive nature of fine-tuning large language models for new data sets. The paper proposes the use of prompts at different levels, including task-specific, domain-specific, and context-specific prompts to enhance the understanding of input semantics. It also introduces an independence constraint to avoid redundancy in domain-specific prompts, and a prompt generator that incorporates context-related knowledge. This method aims to make language models more efficient and accurate in comprehending text. It has the potential to greatly benefit natural language processing tasks and improve the performance of machine reading comprehension systems. The paper, Knowing What LLMs Do Not Know, addresses the problem of large language models, or LLMs, generating incorrect responses due to their lack of knowledge. The paper proposes a novel self-detection method that identifies the questions that LLMs do not know and are prone to generating non-factual responses. The method leverages the LLMs themselves to diversify question verbalizations, generate candidate answers, and examine the inconsistency between the responses to detect unknown questions. The paper's contribution is evaluated on various tasks and achieves superior performance compared to existing methods. Okay, that's all for today. And we covered a wide range of topics in today's session, including fine-tuning language models for autonomous systems and negotiation dialogue agents, prompt generation in large language, and these papers offer valuable insights and solutions to various challenges in AI and NLP. Thank you for your participation. If you enjoyed my video, I'd appreciate if you could give it a thumbs up and subscribe to my channel. Your support helps me create more content. Thank you. You'll see you tomorrow.